The blood flow rate varies from 0 to 600 ml per minute. We can calculate the blood flow rate by dividing the volume of blood in liters to be filtered by the time in minutes. This may be used in quality assurance, where the blood flow rate must match the one set in the machine. To be effective, the blood flow rate must be accurate and confirmed by senior staff and should be as per the doctor's prescription. Dialysate flow is controlled by the flow pump. The rates may be preset or adjusted as per the prescription. High flow rates improve dialyzer efficiency only up to 800 ml per minute. The range is 0 to 1000 ml per minute. Normally, a flow rate of 500 ml per minute is set. Dialysate flow rate may be due to low water pressure, dialysate pump failure, blockage in the flow path, or power failures. Air can cause death if it enters the bloodstream of the patient. 150 ml of air, if it enters, can cause death. Air and foam detectors therefore continuously check the blood for air in the venous drip chamber. Air is sensed by the ultrasound detector at the venous chamber. The status line populates with the air detector alarm, and the blood pump stops to prevent air from being delivered to the patient. Hence, it is essential to properly place the venous drip chamber in its holder and set the proper blood or saline level in the venous drip chamber to 2/3. Avoid overfilling. The limits are preset or can be calibrated by qualified technicians. Transmembrane pressure is the difference in pressure between the filtrate and the permeate sides of the dialyzer membrane. It can be calculated by subtracting the venous pressure from the dialysate pressure. To keep dialysate from moving into the bloodstream, the blood compartment pressure must be equal to or greater than dialysate compartment pressure. It is dependent on the UF rate, UF coefficient of the dialyzer, and the blood and dialysate flow rate. UF coefficient is a measure of permeability of the membrane to water. It is measured as ml per hour per millimeters of mercury. It indicates membrane status on a patient on a particular day. Based on this, dialyzers are classified as high flux or low flux. The TMP may not change substantially during UF errors when high permeable dialyzers are in use. Increased TMP may be because of thrombosis in the dialyzer, thickened blood due to recirculation, mismatch in the blood pump speed and the UF rate, and secondary membrane formation at high UF rates. Reduced TMP may be because of degassing procedure, defective connections, and ruptured dialyzer. If you are unable to reset the alarm, discontinue the treatment and notify the technician.